We'll proceed in vector algebra and calculus. Okay, so the most advanced thing in calculus in mathematics is considered as vector. Whatever is the most advanced thing. If someone goes the most advanced topic in numerical mathematics, all right. If someone goes most advanced idea in algebra, all right. If someone goes most advanced technology in coordinate systems, all right. If someone goes very advanced kind of scenario in trigonometric, all right. If someone goes very advanced kind of scenario in calculus, all right. If you want, if you want direction in it, if you want a direction, then it is vector. Vector itself is not a science. Whatever science someone has, if you think that it should show its direction also, then it is vector. A numerical science with a direction is vector. Algebraic science with a direction is vector. Different coordinate system with direction is a vector. Trigonometric function with direction is a vector. So wherever direction comes into the picture, it is vector. If I say I have magnitude of 2, that is one thing. A person is walking. I have taken this example. Person is walking in kind of uh, uh, 2 kilometer per hour. If someone is saying 2I, then he is walking at 2 kilometer per hour and his direction is I. I direction, someone say it is east, minus I is west, and J is north, and minus J is south. Or if he is flying, then it is K, Z axis. So rather than saying he is direct in this direction, that direction, someone can simply say I, J, and K. Rather than saying this much longitude and this much latitude, I believe if that is the case, then somewhere on the equator, someone can set origin. I believe that origin can be Cairo, near to the Cairo. No, no, no. I believe Cairo is on a Cancer line, near to Cancer line. So somewhere near Congo. So Congo is on equator. Somewhere near Congo, that would be all right because its westward is South America and North America, and eastward is the Asia. North is Europe, and south would be Antarctica. So all right, so Congo, someone can set as origin, and from there how much I and how much J. Okay, if something is flying in the sky, then he can say how much I, J, and K. If it is minus K, then other side of the earth down he is flying. So this is the vector. If we need a direction, then we need a vector. So vector is nothing, not a separate technology. Any technology, if we want to explicitly specify the direction, then it is vector. Anyway, we, not only that, vector can be used to find the curve length. This is what we have seen. It is not possible other way. Vector can be used to vector can be used to get the surface area of a sphere. Surface area of a sphere, vector can be used to get. Okay, so one way of calculating surface area of the sphere through the, now we have seen too many things, too many items in calculating the surface area of the sphere, too many ways. And the prominent way in Cartesian coordinate is calculating the, considering if I have a surface, then take any point P on the surface. If I take any point P on the surface, from origin, draw a vector to that point P. And the vector would be xi plus yj plus zk. If that is the P, then we find dp by dx. That is the velocity vector. I mean, I'm not Now, no way I am considering the primitive calculus, modern calculus. Now we are considering only velocity vector. So if P is the position, there is a surface. On the surface, not inside it. On the surface, I take any point P and coordinate it x comma y comma z. Coordinate is x comma y comma z. In that sense, if I draw a vector from origin, that is called position vector. Someone can say displacement vector. And then dp by dx is velocity vector, that is partial derivative along x-axis. dp by dy is the velocity vector, partial derivative along y-axis. dp by dx cross dp by dy, if this is the dp by dx and this is dp by dy, if I calculate the cross product of these two vectors, it gives area in between. Now dp by dx cross dp by dy, if I calculate the magnitude, it is called surface velocity vector. I'm sorry, dp by dx cross dp by dy, if I calculate, it will resolve into vector again, and that is called surface velocity vector. Calculate the magnitude, surface velocity magnitude. Integrate with the xy plane, you get the displacement back. In high detail, we have demonstrated this in past 2 or 3 or 4 videos. So that someone need to must be watched. So that is the scenario. Not only that, we proceeded in this, and instead of dp by dx cross dp by dy, we took a spherical coordinate system. So when it is a spherical coordinate system, then dp by dx cross dp by dy, we change into dp by d theta cross dp by d phi, and then d theta d phi. How it happened, please watch previous video. We have demonstrated quite clearly out there. So dp by dx cross dp by dy is nothing but d surface area by dxy plane. Then we integrate with dxy plane to get the net surface area, because d surface area by dxy plane is called velocity vector. Now I can multiply with d theta phi by d theta phi. dxy cut down, then it becomes d surface vector by surface velocity vector by d theta phi into d theta phi. This becomes dp by d theta cross dp by d phi, magnitude d theta d phi. If we do so, then dp by d theta cross dp by d phi, where p is the position vector, that is xi plus yj plus zk. If Cartesian coordinate system and spherical coordinate system, if someone maintains the mapping, then it becomes x equal to r sine phi cos theta I, y equal to r sine phi sine theta j, and k and z equal to r cos phi. Okay, that is the scenario. Okay, that is the conversion of coordinate system. Now here r is constant because we are talking only about the surface area, not inside it. So radius, three components are there in a spherical coordinate system. One is radius, one is theta, and one is phi. Okay, now someone is free to calculate. Xi plus yj plus zk is the p, that is a a sine phi cos theta I plus a sine phi sine theta j plus a cos phi k by d theta cross a sine phi cos theta I plus a sine phi sine theta j plus a cos phi k by d phi. If someone calculate the cross product and calculate the magnitude, integrate with d theta d phi. Why we selected d theta d phi, that we will talk. Now, but this is the calculating the surface area through velocity vector, that is true, but it is again in hybrid Cartesian and hybrid model, because we took xi plus yj plus zk as p. Can I take p in the pure spherical coordinate system? That is a concern. dp by d theta cross dp by d phi, magnitude d theta d phi, integration for theta and phi. Can we calculate surface area in this fashion? That is under question mark. Okay, what is the, if I have a sphere, Okay, I do really have a sphere. Okay, I have a sphere, and this sphere, now what are the three coordinates that we will first make it clear? Okay, forget the Cartesian coordinate. This is x-axis, this is y-axis, and this is z-axis. Okay, so probably we will not consider now. This is centered at the origin. This sphere is centered at the origin. Now there is any point P here, any point P here. Okay, any point P here is all right. Now we have discussed that if I say Cartesian coordinate system, then x, y, z are orthogonal to each other. They are at 90 degree to each other. If that is the case, I know there are three components in a spherical coordinate system, theta, phi, and r. How they are orthogonal to each other. So what is r? R from center, the radius of this sphere would begin from 0 to it will go till the surface. That is the radius of the sphere. Okay, phi, phi angle. Phi angle, if from center, if I take vertical side, then whatever the angle it makes, then that is phi angle. Now, if someone would say, again you have started taking vertical. I mean, someone can wait on it. Anyway, now there is a in horizontal fashion again there is a one angle it forms three sides it forms the angle. Now let's cut it horizontally. Okay, so let's cut it horizontally anywhere at the center or anywhere. If you cut horizontally, how many ways this surface, this sphere can be cut? Okay, so that they are independent to the each other. One is someone can cut like this and then he can cut at 90 degree like this. Okay, this is one way. Makes sense? So at any point, I can cut vertically. This is better word. So I can cut vertically or I can cut horizontally from any direction. Up, 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 up. Okay, so I can cut vertically, I can cut horizontally. If I cut it vertically, if I cut it vertically, then it will make a circle. If I cut it vertically, I make a small slice of it vertically. It will make a circle. If I cut it, what you see is a round shape, circle. There is a if there is a circle, if I cut it vertically, these all are vertical ones. All are vertical ones. If I cut it vertically, then there is a circle like this. If I cut it horizontally, then there is a circle like this. Make sense? So they are 90 degree to each other. This this cut, this cut is either YZ plane or XZ plane. If I talk about, let's not talk about Cartesian coordinate. One I can cut like this, one I can cut like this, and they are perpendicular to each other. Make sense? So if I cut like this is the arc. And if this is the arc, along the arc, one radius can move. If I say this is a circle, then someone would immediately find this is the center. If this is the center, then there is a radius. If radius is moving like this from the center, it is making an arc, and there is an angle that is growing. That angle is called phi. Now from here, perpendicular like this. Now if that is the case, then if I take a radius and move like this, there is an angle moving. That is called theta. Both are perpendicular to each other. Now what is the third component? That is radius. Radius is perpendicular to both of them. If you take, the radius is perpendicular to the arc. If you take in this plane, again radius is perpendicular to the arc. Okay, so radius is always perpendicular to the theta, the arc that is made by theta, and radius is also perpendicular always arc that is made by phi angle. So this expression is not available anywhere else, I guarantee you. So if that is the case, then there are three orthogonal components. One is r, one is phi, and one is theta. The arc that is made by movement of phi, that arc. So now consider that this is the vertical arc because it belongs to vertical circle. This arc and horizontal arc, they are at 90 degree to each other. And from center, if you take radius, then again it is 90 degree to this arc also and this arc also. So all three are perpendicular to each other. So a spherical coordinate system is also orthogonal coordinate system where theta, phi and r are perpendicular to each other. But theta is represented through arc and phi is also represented through arc and radius is a straight line anyway. Okay, so that theta arc, if I talk in a vector form, then it will be represented by the tangential vector or arc vector. Someone can say it as a curve vector also. So if this is a theta circle, then this is the tangential vector at any moment. If this is the phi arc circle, then this is the this is the tangential vector at any time. Now, what is the tangential vector when it is the vertical circle and what is the tangential vector when it is horizontal circle? These are the vector and radius is radius vector. Anyway, it is a straight line. So there are three lines. One is phi vector, one is theta vector, and one is radius vector. They are orthogonal to each other, and that is how the spherical coordinate system actually it has deep presence in coordinate system. It is not like the way it looks like. It is completely orthogonal component. Now, if that is the case, the first way we will try to find out the surface area. Now this horizontal circle can be at the equator at the center or I can cut chop at the any location. It is always horizontal circle. Radius will be different. If I cut at the center, then horizontal circle radius will be radius of the sphere or otherwise it will keep on decreasing if I go below and up. Similarly, if I cut at the center, then that circle, whatever circle we are getting, that radius will be A only. That is the radius of the sphere. Otherwise, if I cut along here and there, circle will become smaller and smaller. Okay, that is the concept. Now the question arises, what is the surface area? If I have any point P here, if I have any point P here, at point P, what if I take a small, kind of arc section in theta and small arc section in phi. Now this arc, vertical arc is represented by angle phi that goes from 0 to pi, and horizontal arc is represented by angle theta that goes full to pi. Now, if I talk about any small region here, then what is the surface area of this region? Then that is nothing but if I say vertical arc as V, vertical arc as V, vertical arc as V, then it is delta V and horizontal arc, vertical arc at delta V, horizontal arc at delta H. That is a small section I have taken. I am trying to calculate the delta A. Delta A equal to delta V into delta H. Or rather I would say vertical arc, the vector, vertical arc vector and horizontal arc vector, if I do cross product, that will give me the small area out there. Then that is delta V phi vector. Anything I can represent, right? Delta V phi vector. Phi vector means it is in phi direction. Cross delta H theta vector. Here radius is not coming to you. The radius is constant on the surface. Only phi is changing and theta is changing to make the surface. So what is the delta area? Delta area is delta V, that is the vertical arc small phi vector. Okay, cross delta H vector, delta H theta vector. This is the kind of, if I make cross of phi vector and theta vector, it will go into other direction, that is r vector. So this multiplication will be delta V into delta H, delta V into delta H R vector. What is delta V? What is the vertical arc, small delta vertical arc direction? Okay, that is under question. Now, if this is the radius, if this is the vertical circle, okay, this is the vertical circle and this is the radius. If I move delta phi to make delta V here, if I move delta phi where delta phi tends to 0, that's why the delta V phi vector, this is what we are saying, right? That is tangential. Otherwise, it will not be tangential. It will become connecting 2 points on the arc only. That also we have demonstrated very nicely. So then now the delta V phi vector, if we are talking the vertical arc, then that is A d phi. A delta phi is the length of this vector. A delta phi. A delta phi. What about horizontal length? Horizontal length is the radius into delta theta. So I did not say radius of the sphere, but here guaranteed it is radius of the sphere. Why I am saying like this? The vertical arc, I am saying the radius of the sphere. If you crack it, then you crack it. I mean, someone need to crack this. So vertical arc when I'm making at the center only. The circle that is coming that has full radius of the sphere A, but horizontal. If I say any point P here, right? Any point P I have taken, there delta A I am calculating. That P I consider at any point P. So at the point P, I cut at the center of this. That will touch any point. If I take point P here, again I can cut at the center. All right, right? But P is here, then I have horizontally, I have to slice it here, where center is here. So it will be at height something. If that is the case, the slice will have radius that is smaller than central radius. But vertically, I am cutting at the center one. Okay. So vertically, if I am cutting at the center, the radius of the circle is A. But horizontally, if I am cutting, the radius is R. That is not A. At the center, it was A. Okay, anyway. Now, the kind of delta H component is R, whatever the radius here is, R delta theta, theta vector. Anyway, we have multiplied it and phi vector and theta vector, it became R vector. Since it is only one vector, I can leave it because a square and a square root magnitude will be same one. So, all right. Now, the vertical delta V is A delta phi. Horizontal is R delta theta, where R is not A. R is dependent upon at what height I am cutting. That is the radius. Make sense? If I am now, if this, okay, if this is the, if I cut at the center of the sphere, then this circle have radius A. If I cut little bit high, then radius will be smaller. In that case, this is the top circle where I cut it, and this is the middle circle. This is radius of the sphere. This is a small radius and this is big radius. In that case, this is the angle phi. Then if that is the case, then A sine phi is this radius. Makes sense? This is vertical and this is horizontal and this is phi angle from the vertical. So A hypotenuse. So A sine phi is this become vertical for this triangle. A sine phi is this radius. So I can say A sine phi d theta, delta theta is the horizontal arc at any point P. Vertical arc is A delta phi. Now we came to conclusion that delta area at any point A is A delta phi into A sine phi delta theta. That results into A square sine phi delta theta delta phi. That is the area of a small rectangle at any point P I take. I am not talking about x, y, z. If that is the case, to get the full surface area, I can integrate. I can take a small pitch, a small patch everywhere on the sphere, and I add it. That will come as the integration one. So it will come as integration from 0 0 to 2 pi, that is theta, and 0 to pi, that is phi, and then a square sine phi d theta d phi, or a sine phi d theta a d phi. A square I can keep outside. Sine phi, if I integrate, then it becomes sine phi d phi minus cos phi, 0 to pi. That will come as 2 cos phi minus cos phi, pi, then minus minus 1, 1, 2, positive 2. 2a square I can keep outside, and theta 0 to 2 pi, 2 pi, 4 pi a square is the surface area of the sphere. Amazing, mind blowing. So this is the way I can calculate surface area of the sphere through the spherical coordinate system only. We don't need xi plus y dot, point is x comma y comma z, and then consider x equal to a sine phi cos theta, y equal to a sine phi sine theta, and z equal to a cos phi, and then not required. Directly we can do. Okay, can someone try with there is one more way someone can try. Okay, if this is the point P, then vertically I can cut it here. Okay, and horizontally someone can try other way. I don't think. Okay, I thought that someone can try reverse fashion, because what we did is we cut it horizontally here, that the circle became a smaller, and we cut vertically from the center, and circle was exactly complete. If someone can try, think of the other way. This is what the concept. Anyway, now the idea is, can we calculate the surface area through velocity vector, through the velocity vector? Surface area through the velocity vector in pure spherical coordinate system. Okay, if that is the case, I take any point P out there, any point P, then dP by d theta cross dP by d phi, magnitude d theta d phi, and integration. It will give the surface area. Now question is arising, what is the P vector? Okay, if I talked about Cartesian coordinate system, it was xi, yj, and zk. So these are the three vectors. Xi is the x vector, yij is the y vector, and zk is the k vector. So that is the P. Now if I talk P in the spherical coordinate system, then I have to think about theta. These explanation is not available anywhere else. Please do support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. Anyway, if that is the scenario, then what is the position vector P in terms of a spherical coordinate system only? Then these are three vectors. One is theta vector, one is phi vector, and one is r vector. Okay, if that is the scenario, then what is the theta vector? Theta vector is a sine phi theta and theta vector. A sine phi theta. Theta, the way we say x, I, y, j, z, k, right? Like that, because the theta means the arc. Arc represents the theta. If this is the theta, then the circle arc. Arc means arc vector. Arc vector represents the theta component of the spherical coordinate system. Phi is represented by the vertical arc. That is the vertical arc vector that is tangential at any point. That represents the phi vector. So this is a vertical circle. Then this is the phi angle that is moving. Then this arc it represents the phi angle. Then the arc vector, curve vector, or perimeter vector, that represents the phi angle, and that is a, that would be a phi vector. A phi, at any phi angle, that length would be a phi vector. So if I say all three, then I represent at theta, r, and phi. Then the xi plus yj plus zk, what we think in Cartesian. Similarly, the position vector will be a cos, a sine phi, a sine phi. This is what we saw, right? That is the curve for the theta. So a sine phi theta, theta vector. plus plus r vector, or if it is surface, then or r vector. So r vector plus a phi vector. Okay. Now I have to say dp by d theta cross dp by d phi. If I do dp by d theta, then it becomes a sine phi. Theta is become 1. Okay, and theta vector. R is gone. There is no theta there, and phi is gone. No theta there. Okay, that is a d phi, a phi vector. So only thing remaining is I vector if I differentiate through theta. What about if I differentiate through phi? Then it becomes a cos phi. A sin phi becomes a cos phi theta, and theta vector. Next is gone, and next is a my a. It was a phi, so it becomes a phi vector. Now I have to do cross. This is our proof. Search anywhere. Now, now we have to cross the first. The dp by d theta is a sine phi theta vector cross a cos phi theta vector plus a phi vector. If I do cross product, then theta and theta cross is not possible. Theta and phi cross is possible, and it will go in r vector direction. So if that is the case, then it is only one, so I can leave it. So theta phi cross product is possible. So here it is a sine phi, and there it is a. There it is a square sine phi, d phi d theta. Don't you think so? It came to same thing. A square sine phi d theta d phi. And then if you integrate 0 to 2 pi and phi, 0 to pi, a square sine phi, it will come as 4 pi a square. Amazing, mind blowing, right? So this is the proof that we are doing in the scenario of only a spherical coordinate system. We will proceed in more thrilling vector idea in calculus, vector algebra calculus. So now people are independent. Post this session, anyone would be independent. He can think. Only thing is, think in orthogonal fashion. I have theta, that is the angle. I have phi, that is the angle, and r is the line. Then how I can represent in vectors? Theta is represented by the arc, curve vector. Phi is represented by the arc, curve vector, and then radius vector. That's how they are orthogonal to each other. Not because of the angle, they are orthogonal to each other. These explanations are also not available in any of the book. Why a spherical coordinate system? All three components are orthogonal to each other, theta, phi, and r. No one knows. Only it is moving from 0 to 2 pi, one is 0 to pi, one is 0 to a. Why they are doing like this? No one knows. Okay, we'll proceed in very thrilling vector terminology where we are adding direction also. So the calculation where direction is important, like surface area direction is important. There certainly it will make sense. How many oranges someone is saying that I am getting oranges. I am getting oranges from someone. And how many oranges I am getting? Someone say, I'll tell you direction also. I don't bother, because orange if I take, I'll immediately eat it. So only the number matters, not the direction in which coming. So wherever direction matters, there vector comes into the picture. Not everywhere direction matters. So that scenario. Anyway, so further to it, amazing, mind blowing, right? So that we will